Hello.
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 I would suggest folks adding their name to the attendees list on our community meeting notes. I will post the link in the chat if you don't already have it.
Should we get started?
I think so. Well, Mike Lieberman is here, so apparently we have demos. Michael, are you ready for demos?
Sure. Give me just 1 second. I know some of the folks have seen this already. Let me just double check and make sure I have sort of reset the demo to since the last time I gave it, just so that it's I can show off all the different build.
And while you do that, I will briefly stall for you by saying that I was at the Open Source Summit last week and talked about various things, including a shout out about mentioning SLSA. So, so there are people who've heard about it.
Yep.
Dan, did you want to add something?
Oh yeah, lots of mentions of it. There's going to be even more Monday at KubeCon. I was just going to ask if maybe we could start a list in here for people that will be at KubeCon, so we can all try to meet up while we're waiting.
I will not be there, but I wish the best.
All right. Oh, sorry. Go ahead.
Go ahead. So there's a list for those who are attending KubeCon at the bottom of the SLSA community meeting notes for today. Go for it, Michael.
All right, cool. One other thing I just wanted to actually add on there regarding what you were just mentioning about SLSA becoming a lot of people talking about it. I'm also involved in the Nix and Nix OS community, and some of the folks there were kind of very interested in seeing how they could start to see how some of the Nix tooling and stuff that they're doing over there, how that could be used to sort of prove elements of SLSA. All right, cool. So let me get started here. Can everybody sort of see my screen? Do I need to make anything larger? Everything good? All right, cool. All right, so this is, I know some of you have seen this demo if you've seen me give it at the CNCF or some other places. But I'm going to run sort of an example secure software factory here And so this is a combination of different tools operating inside of Kubernetes to sort of show what a secure build system for a secure supply chain might look like. And I'll show how also this relates back to the SLSA stuff by actually showing at the end doing admission control based on attestations. And I'll also show how we need to really consider different pieces in here in order to really we need to consider the whole thing, the big picture holistically, and that all it takes is for one small gap for a supply chain compromise to make its way in there. So just to kind of give the high level here, right, it's doing some basic stuff. I'm just sort of cloning. I'm, using Canico to build. I'm generating SBOM on the source files. I'm, doing some other stuff here, and so on. And so all of this now, so it's using Cosine behind the scenes. It's developing attestations and so on. And so if I go in and quickly do a LS here, you'll see this is the image itself. This is an SBOM of the source files. This is a signature for that SBOM. Here is chains attestation that for what actually happened in that build. And here is a signature on the actual image. So if I want to just show you what this looks like, I can do whoops. Oh, 1 second. Let me just. All right, my machine crashed, so I just have to change this to the other thing here. 1 second. Okay, so this is an attestation. And so what I can actually do is if I want to fetch metadata, if I want to actually get the data associated with that attestation, I can, whoops, I copied, pasted wrong. Hold on. Right, I can look at what the actual sort of build was doing, and it's going through all these steps. Something to sort of note here is I am using for the actual inside of the namespace where the build is actually happening. I am using Kyverno as an admission controller to validate the actual keys of the images validate that the images are signed with the right keys. So I'm making sure, hey, anything that I'm pulling down from Tecton is signed with the Tecton key. Anything that I'm pulling down from SigStore is signed with the SigStore key. Other things in there are signed with my key, and so on. And so all of this great stuff, cool. I have attestations, I have signatures, I have all this sort of stuff. What could possibly go wrong? So let me show you. So if I pull down.
So Michael, I had a quick question. Like in this demo, can you tell like what are the technologies you are using and what is the custom code you created or glue code on top of it at a very high level?
Yep. So there's a handful of things in here. So a lot of this is described in more detail in the CNCF's reference architecture document for the Secure Software Factory, but at a high level, I'm using Kyverno and as well as OPA Gatekeeper for two separate use cases for admission controller. Most likely would become one as some of the features sort of coalesce. I am using a bit of custom code as a wrapper API around cosine to actually query, do some of the querying for the admission controller, right? Because the admission controller, in the case of OPA Gatekeeper, it can make HTTP requests. It doesn't really know how cosine works itself. So you have to say, hey, make an HTTP request. It returns some JSON and it'll do some stuff. And a lot of that work was based on what the person who goes by developer guy on CNCF and some of the other Slacks, it's based on some of the work that him and a few other folks had done. And then also using Tecton and Tecton chains as the actual CI/CD system. And I'm trying to think if I'm missing anything. I think those are the primary technologies that we're using there. All right. And so if I pull down this image and I run it, oh, I forgot to actually mention what the actual code looks like, the code that I just built. So if I show you, it's just a very, very, very simple hello world program, right? So that's what I'm building here. Oh, that's weird. Why does it say goodbye world, right? Like it should have ran hello world. It pulled down, if I go back here, right, and I look at what it cloned, right? It cloned this code from here. If I go and show you what that code looks like, right? If I go to the source, it says hello world, right? What went wrong? Well, you know, to spoil it for you a little bit here, right? I have a I have over here, I have a Docker file, right? That is supposed to be the parent builder image of this thing. It includes this Rust latest thing, but I'm actually replacing Cargo, the Rust compiler, with my fake one, right? And because I wasn't validating the actual parent images, well, the parent images of what I'm building, oh, that's it didn't get caught, and so that's how the bad code made its way in there. So what sorts of things can we start to do to sort of validate that? Well, one of the things is we can also validate, like in the case of using Canico or another agentless, rootless sort of builder, we can also validate the parent images. So if I go in and change Canico with cosine here, and I do this. So now I have a task in here to sort of validate the parent image. Some of this I believe is there's an open GitHub issue to do some of this validation in Canico itself. But for now we could just use cosine to sort of do some of that validation for us. Right, and so it fails. Why does it fail? Well, it's not, this hasn't been signed with the right key. So if I now go in quickly and build sort of the real one, which I've already signed and everything else pushed out, and rerun it one more time. So this is now against something that we've already pre-approved the image. This is assuming that, we're using the right digest, we've signed it, we've validated that, whatever this image, we validated that parent image is good. Now it should go through and actually build it correctly this time. But once again, for everybody here on this call, as we all know, right, like a lot of this stuff has to be validated. It's hard to sort of do it all, but we need to really think about the problem holistically. And one second. let me wait for this to sort of finish. And so once again, this demo makes some assumptions, right? Some of the assumptions that it's making is that largely, right, that your root of trust is fairly, your root of trust hasn't been compromised already, is sort of some of the assumptions that are being made in this demo, right? Where some of the assumptions that are being made in this demo is that, whatever, like I'm using AMD, right? AMD hasn't been hacked and their processors are not compromised, right? And I'm assuming that Kubernetes hasn't been compromised. I'm assuming Tecton, right? And Cosine have not been compromised here. But assuming those things haven't been, and that's where I'm sort of rooting my trust, then I can do some of these extra things such that as stuff comes in, I can validate and so on. And so if I go here, you can see, yes, this parent image over here was validated. Now, in this case, right, I'm still not using best practices, right? I would most likely just always pin to an individual digest, and in addition to checking that those digests are signed. But for the sake of the demo, that's, you can see all of this. Now, what I can do is I can rerun, right? It will have all the same sorts of, it will have all the same sorts of attestations and signatures and so on here. Right, and now it says hello world. Now, one extra step here, right, is, okay, so now that we've shown how we can do all this, how we can do all these things to sort of secure, your builds and secure the supply chain, what can we do now to sort of say, okay, well, when I move this thing to production, right, I only want to run stuff that has gone through these, attestations and so on. Like, I want to validate, hey, does this thing have the correct SLSA attestations? If not, don't let it run. So that's where the other admission controller comes into play, which is the OPA gatekeeper one. And so let me show what that looks like real quickly. Right. So once again, I'm not an expert in OPA gatekeeper or anything like that. So don't my Rego might not be the best. But the basic idea is I have two things that I'm checking. One is that, hey, is this signed with my image? Is the image signed with my key? And in addition to that, does it have the required attestations? And so what this is actually calling is it's calling a wrapper API around Cosine to do this. Once again, based on some of the work that some other folks in the community have done. But so let me show you what happens if I try to run something that isn't signed. Right. So I try and use this random curl image in the, quote unquote prod namespace. This is the namespace that is, for the sake of the demo, is the namespace that we're using as, where the admission controller is actually validating access, or sorry, controlling access. And so you can see here, doesn't have a valid signature, doesn't have valid attestations. But if I do, right? But if I do this, right, if I do that image that was signed, had all the right attestations in the prod namespace, it works. Why? Well, it has all those right attestations and so on. And then one final thing, just to kind of show you where we're kind of thinking about this in the future, right, is if I do, if I use Crane LS again here, right, and I show you, hey, there's stuff like the SBOM, right? Now, in general, we want to sort of keep most of the information as like sort of attestations, right? Yes, you have an SBOM that meets these sorts of requirements. And so we're attesting that, yes, you have those things, but it is also still useful to kind of go back into that metadata at some point in time in the future to say, hey, you know what? We just, recognize that there's a bad hash. Like, if we recognize that there's a bad hash that, refers to something, can we go back and now actually look at what's, in one of these metadata files that's associated, lives alongside the image in OCI. And we can, also still perform the same sort of admission control, right? We can do stuff like invalidate a hash and say, sorry, you can't deploy if this hash is found to be in your SBOM, or we can revoke access, and those sorts of things. And then we can obviously still do other higher level things of like revoking the attestations regarding things that have those SBOMs and so on. Cool. And just one quick thing, if I just show you, the other thing that's also useful here is I can now go back at any time and query whatever's in this image by doing right. Whoops, forgot the key. Oh, actually, I think because my computer just crashed yesterday and I had my key in the wrong place, I might not be able to show this. Right. There we go. Oh yeah, let me type into JQ here. And so like, for example, here is a Cyclone DX SBOM of the source files, right? And so because all of this sort of stuff lives alongside the image in OCI, and because it's more or less content addressable here, right? This SBOM is the digest here, right? Right? It's this digest, with some extra little thing here, .sbom.sources. This allows me to know, yes, this SBOM refers to this thing, and this signature over here refers to this SBOM. And there's some additional things we can do with attestations to sort of provide some additional guarantees. Cool. That's the main part of the demo. Any questions?
Yeah, I have a question actually. I saw you using Kyverno, and then I saw you using Gatekeeper, and I was wondering why I was seeing both in the same ecosystem. So.
Yeah, so a couple of reasons, mostly just sort of practical reasons for the demo. One of the reasons is Kyverno makes it very easy to do stuff like this. I can just give it a key, and it'll just be able to kind of, it has built-in integration with, I believe, cosine signed images. And so I can just sort of do this verify images and just plug that in there. Now, Gatekeeper itself does not have that ability, but it does have the ability to just sort of make arbitrary HTTP requests. So it can kind of do some additional, it can do a lot more, but it's a lot more complicated. So one of the things in here is, so I wrote up, a wrapper API based on some of the work that some of the other folks in the community have done. And that wrapper API, like Kyverno can't call that directly. So I had to use something else. OPA Gatekeeper can do that, but OPA Gatekeeper also doesn't make it super easy to do some of the other stuff. Like ideally, right, as the admission controllers get more, feature rich, I would imagine almost any of, you'd be able to pick whichever one suits your particular use case. But in the case of this particular thing, it was just that if I just want to quickly check a key, Kyverno makes it super easy. But if I need to do anything else, like I want to validate information in the attestations, right? If I go back to this, right? If I want to go and say, I'm doing stuff like I'm validating that it has Tecton's provenance format, right? And this is part of that JSON. As far as I know, I can't do that in Kyverno as it stands today. There's some other admission controllers I could probably do it in, but I'm, mostly familiar with Gatekeeper in that sense. And this, it allows me to do this sort of thing, whereas I couldn't do it in Kyverno. But if I wanted to just purely check, if I purely wanted to check a signature based on like who owns that image or who should have signed that image. Right now, it's very cumbersome in Gatekeeper. I believe there's also some work from some folks trying to make a plugin and some other stuff.
Cool,
Did
thanks
that
for that.
answer your question?
Yeah, that answered it totally. I was using Connoisseur for image verification, and I posted a link into the Security SIG Kubernetes group because they're also looking at this process. And so I saw you use both, and I just thought it's like highlighting one of the gaps we have in our, admission controller environment or ecosystem right now. that we can't do this with one nice utility. We have to use, one or the other. And I want to side with Gatekeeper, but writing a wrapper script seems kind of not something I had time to do. So it's cool to see your demo.
I'm wondering if there's room for some sort of tips or something like that. I think it's really important that SLSA not be locked into any particular technology. You know, in fact, I think we really need to scrub it. On the other hand, hey, there are certain things that people are going to likely use or want to do, and here's a way to do it, or here are 3 ways to do it, and reasons why you might use each or something like that. But make it clear that those are just, here are some tips that might help you. These are not required. What do you think?
Yeah, I'd almost go further and say, I think we should recommend a particular suite of things that, like, if you do, like, here's the things that do work, but there's other ways to implement it too. And that's like, that would still be SLSA qualified. I would imagine most people don't want to have to implement it all themselves, but rather like just want to have some turnkey solution. And so having like a suite of things that all work together is probably a good idea. That like the easy path is to do this thing.
Yeah, providing easy paths is great. We just need to make it clear that you don't have to do it this way. These are the requirements. Here's an easy way to get there. Because no matter what, people are going to have other things and other approaches and things they already have. They're going to come to the table with.
Yeah, I just wanted to say that I agree. There's going to be a diversity of tooling here, that's for sure. The other thing we're going to be careful not to do also is that we can't assume that everybody is going to be cloud native, at least for all of the apps yet.
Yeah, I don't think that should be a requirement for SLSA. You should support it, but there's a whole lot of systems that are, standalone. There's a vast number, billions of standalone devices, and we care about those too. If it's a pacemaker, I still would like to have some confidence in its supply chain.
Yeah, and actually to that, what I'm on the agenda for later to talk about that. I have the SLSA reference architecture doc that I'd like to kind of discuss. It's in a very early state, but that also kind of gets toward that of like, what are the general ideas of how this works, as opposed to like, this is specifically how it works, and not being like not specific to any particular build system or not OCI specific, but would work for kind of any package manager. I think that's important. Also, Trishank, you mentioned about OPA and Rego is too limiting. I could mention, and because various folks are talking about the admission controllers, what we've been thinking on the Google side, on the binary authorization side, is that like any of these languages are terrible to write, and most people should not have to write them. And so doing something like OPA Gatekeeper, if you're familiar with that, where some expert writes a template in some policy language, like Rego, that does like all the hard work, but then most regular people just instantiate that with parameters that say like, I expect, like the source repository to be this, or the build system to be that, or the key to be this, and does all the joining. We have been looking at and are working on similarly to what Michael's presented, some sort of wrapper around OPA to kind of make that all happen, because there's really a lot of fiddly bits like checking the hashes and all this other stuff that's hard to get right. And using any of these things directly is just awful. So that's, I think, why it's important to have some sort of wrapper.
Oh, yeah. No, I agree. Without running too much of the agenda over. Yeah, I just wanted to make a comment that we found some limitations that at least OPA doesn't work for us right now. I'm happy to get my colleague in the call next time where he can talk more about the technical details.
Yeah. One quick thing I just wanted to add on before handing off is just when regarding some of the stuff around sort of reference implementation and different things. Yeah, definitely the CNCF reference architecture. We are trying to kind of show some of that sort of stuff off in both a sort of high level. These are the high level requirements that you need to hit in order to kind of get these things, right? You know, you need to have a mission controller that does these things. And then here is a reference implementation. You could use whatever you want. Just wanted to kind of throw that out there as well.
All right, I've got an extra question. I don't know if you can hear me. My microphone's playing up.
Yeah, you can hear. I suggest I would suggest go ahead, but we do have 2 other agenda items. I'd suggest
It was just
on.
a very quick one. Michael, can you say where this code can be found? Because I'm sure other people are wondering.
Oh yes, I put it in the chat here, so I'll post it again. It's under my public GitHub. This is, to be clear, this is not the CNCF reference implementation, but some of that code might make its way in the CNCF reference implementation. This is just purely some of the stuff that I'm also going to be demoing at KubeCon and some other stuff. People are more than welcome to sort of poke around with it, use it as they see fit, you know, ping me, ask questions.
It's also in the notes, which is more important because the chat disappears when our meeting ends. I'd suggest we move on because we're running out of time. Is that okay?
Who is the owner of the next time? Is that you, Abhishek? There's no name attached to it.
I don't know who added that one. The Salsa Roadmap Workshop write-up. Let's see.
Dan, was that you?
Not me. It could have been Kim. She lost power today. There's some PG&E thing, so she's not here, but it could have been her.
Ouch. Okay. Mark Lodato, was not you?
If nobody
Was not
claims it,
me.
we can skip it.
Yeah.
Okay. We'll defer.
Yeah,
I was defer to next meeting.
Yeah, I was on leave when that workshop happened.
Yeah, this looks like a document from projects by IF that they might be doing some research. So yeah, we can skip it since Dave hasn't come to this meeting.
Yeah, let's move it to the next. You could just copy it to the. Yeah. Thanks, Tristan. Okay, so I could present on the reference, another reference architecture. Let me. How do I present? To Chrome tab.
You should be able to share screen at the bottom. Ooh, looks like you have found success. You're sharing, Mark.
Mark, I'm not sure if you're talking, but you are muted.
Mark, we see your screen, but we don't hear you. And I actually don't see your face either. Oh, you are now unmuted. Don't see your face and
Yeah,
don't see your
that's a
screen.
Zoom. It said when I shared my screen, it muted my phone or my microphone. I don't know why. Let me try again. I will
Okay.
click share.
Awesome. I can tell you it's not supposed to do that, and that doesn't help you at all.
It's easy to inadvertently click on the mute button when you're sharing because it throws the control panel up to the top.
Oh, because there's
Okay.
this audio share button. There's an audio share button that mutes you. Okay. All right. Sorry, I've not used Zoom before. All right. So the idea, we're trying to put together a demo for like kind of getting around showing off the ideas of SLSA kind of at a higher level, of more end-to-end and more of like a macro level of like what is the value of SLSA. The demo showed by Michael is I think more of a specific implementation, like how you could do this today and like how you could realize it. For this is more of like how can we kind of change the industry, like an ecosystem as a whole, and how could we get, for example, all packages on PyPy to be validated or something like that. That's kind of where I'm going. So the main value proposition that I'd like to show is I propose, and we could discuss this, is that SLSA provides value by tracing back to source. At least my main use case for thinking about how using SLSA for something like NPM or PyPy is that when I see a package on PyPy and it says the source code, the source repository is github.com/blah, blah, blah. How do you know it actually comes from that? You have pretty much zero guarantees. You're just trusting that the authors, more specifically the people who have access to the credentials that can upload, actually have actually did that, and you trust that they faithfully did it. And so the value with SLSA is that you have some independent, like you don't have to trust those individual authors. You can trust some other organization that maybe you deem more trustworthy. So for example, if it's built by GitHub Actions and you trust GitHub Actions, you don't have to trust tens of thousands of different projects that use GitHub Actions. You could just trust that as an organization as a whole, or similar to Circle CI or whatever build platform. If we tie this back to a hardware root of trust, which is something that we've been thinking about, then it could be like you trust the software in AMD, but you don't have to trust any particular organization. So that's kind of what I'm trying to get across. The overall picture is pretty simple, and the idea, which we don't have documented yet, but I would like to put on the SLSA site somewhere, is that the builder generates some sort of provenance. It gets stored somewhere, and then ultimately an admission controller decides whether a given package is okay, given a combination of a package, a policy, and some evidence in the form of attestations, whether it meets some requirements. Like it's a fairly straightforward idea. This type of model, I'm just trying to document what the overall model is and give terms to these. Again, this matches what Michael just presented earlier. I think we will probably also need source attestations that says like a particular git commit lived in a particular repo. In the case of like situations where you build from a mirror or something like that, or the builder doesn't actually know what repo it pulled from. Internally within Google, we have that use case, and so we're building this internally and plan to kind of, once we have like something that actually works, we'll make that public. So sorry if there's comments. It's hard to talk and read at the same time. So please just interrupt. It's hard. So what I'd like to do in this kind of almost MVP or demo is just kind of have a working end-to-end system for something other than OCI, because there's kind of a lot of examples of Docker and OCI working, like Michael's example, and that one's so I'm trying to feel like how can we have a demo that works for any package manager regardless of technology. So PyPy, Maven, NPM, anything. And so I kind of go into like how can we like the main work streams are how do we generate provenance, how do we store and propagate provenance, and then how do we perform some sort of policy that determines whether an artifact is okay. Those are the three main work streams. So I try to like to break it up along those lines. The kind of the SIG store model, cosign model, is that the attestation store is within a package repository itself. That is kind of a special case of this. I think it's a particularly good model. It has a lot of nice properties in terms of reliability, but it doesn't always work. So for example, if you wanted to do this in Py, I'm making a claim, so please correct me if I'm wrong. I think if you try to do this in PyPy, it wouldn't work because there's nowhere to stick the attestations. You could stick it, you can't stick it inside the packet. Well, I guess maybe you could as like an extra file, but in a lot of package managers, there's nowhere to stick this extra information. You can't stick it in the package because it has to have a hash of the package itself, so it would be circular. Cosign gets around that by having the special labels that are hash.att or hash.sig, but that doesn't always work. In terms of like the three main questions, like how do you generate provenance, how do you propagate it, and then how do you verify it? The three main options I've been thinking about for how to do that are, one is the build system itself could generate the provenance in some sort of trusted control plane. So using GitHub Actions as an example builder, like GitHub itself would generate the provenance and attest to the fact that it is all true. I think that's the best model, but it like requires convincing all these builders to make a bunch of changes to their system, and so that's kind of a no-go, at least for the initially. Another option is that, and this is what we already have demos for, is that the user-controlled, like the tenant on the build system generates the provenance. So like you could do this in your GitHub, like as a GitHub action, or if you're using Azure pipelines or Google Cloud Build or Circle CI or whatever. There's kind of just like one of the things you run within that generates the provenance. The main downside to this is that you then have to trust all of the security of the CI system. That thing has to have access to the cryptographic secrets. You have to trust that none of the people who run it have gained access to those secrets. You have to make sure that nothing runs on the CI steal those secrets. It's really hard to get right. And as an external person, it's really hard to verify. I have to trust all these different organizations. I have to trust, like if I verify curl, I have to trust curl. If I verify PyYAML, I have to trust PyYAML, et cetera. So like the total trust base of like all packages that I depend on is huge. So that's not particularly desirable. And so something that I put together a little demo for that I'm working on, it's kind of in a weak state right now. There's a link further in the doc if you're interested, is something that scrapes the existing build logs of a build system. So for example, GitHub Actions has a metadata API where you could get information about runs. And it also has an artifact upload artifact action. You could piece these together and actually generate provenance. And if you trust this kind of provenance scraping service, you could then have a trusted third party that generates provenance, which kind of consolidates your root of trust. You now have to trust GitHub and the scraper, but you don't have to trust 1,000 different projects that use GitHub. I think it's an appealing model that I want to kind of consider doing. I don't think it's the right long-term solution, but in the short term, it kind of shows the idea. And so that's one thing we're working on building. In terms of the attestation storage, this is kind of where the doc, it's still half sharing. I'm just kind of sharing work in progress to kind of let folks know where we're going. The main two models are you either have like some sort of central storage thing, like Recore could be an example where you store it on the attestations on the transparency log, or you store it inline in the package manager. Both those have advantages and disadvantages. Matt Swozo, who's I think on the call, and I have been trying to come up with just a general metadata store that doesn't depend on, that's like kind of just a dumb store just to get something working, so that you don't, like with Recore, it is like you're kind of in the whole SIG store model. We'll look at it. Basically, I just want something that works, that we can just get done quickly. Yeah, David?
Yeah, so I had a comment, and this is, please apologize, this is really out of left field, and in some sense it's left field for me. At the conference last week, Ava Black presented to me a very different, interesting model that I am still trying to think through the pros and cons of. But Ava's basic idea was to, in the long term, tweak the compilers to record the hashes of all their source code inputs. And in the interim, it's not hard to create a shim that notices, hey, my build process opened a file, I'll take a hash of that input. And then generate basically a hash of the list of hashes that are used as input. It's not exactly provenance. It's really hashes, because you don't know where, I have sources, I know what the inputs were. I don't necessarily know where the inputs came from. So it's not exactly provenance, and the result is not exactly an SBOM, because again, it doesn't tell you where it comes from, it just tells you the hash. On the other hand, you have very strong information on exactly what went into the build process. Here's the hash. Assuming the hashes have, are cryptographic hashes and have good cryptographic hash properties, you know what the inputs were. And I'm wondering if maybe that could be another approach. Pros and cons. And I just saw this myself, so I haven't thought through all the ramifications myself.
So I think that sounds, in terms of like this model, that would be the case where like the user provided tooling does it. My main question is, from like a trust model, why do I trust that any of that information is accurate? Like I would have to, like, let's take the PyYAML's the example is here. Let's say PyYAML did that. I now have this attestation that like here were the inputs and here were the outputs. What makes me believe that it's actually accurate? I probably wouldn't. I have nothing to believe that that's actually accurate. If I want to convince myself, I could look at their code. I could look to see how it's configured. I could maybe look to see how the keys are protected, and maybe I could kind of do that. But it's not scalable. It's not automatic. I think that from my perspective of protecting integrity, that like prevent people from tampering with the process, I feel like coming something at the compiler level is too low level. I kind of am more interested in like the overall process. Like consider the build as a black box. Any sort of compiler level stuff seems like it is a useful information, especially for like vulnerabilities and licensing. But it almost seems like it is a different use case. Like it is, and it is not.
Or at least a different threat model.
Yeah, different threat model. Yeah.
I mean, if you don't trust the compiler, if you don't trust the compiler, for example, then you have a very different kind of use case. I have some work in that area.
Well, I think another point is just that it moves trust from the like build system control plane to the data plane, right? You're now trusting the environment you're doing builds, because that's where the compiler code is running, right?
Yeah, I'm not entirely sure that you're removing it. Again, if you take what was generated by the build and going to run it later, you are trusting it.
I'd suggest that there's part of the difficulty is trying to find the one true trust rather than accepting that all trust is a matter of subjectivity. Literally, who is the subject that we trust and to what degree and at what time do we trust them? Self-promotion alert. I wrote that article, requirements for a universal asset graph, and I do talk about subjectivity as one thing that should be encoded explicitly in the trust model. You don't have to stop talking and be stunned. I mean, it wasn't that brilliant an insight.
Yeah, and I'll always try to tweak the difference between trustworthiness and trust, because in the end, trust is the decision. But what we're trying to achieve, of course, is various evidences of trustworthiness. But your fundamental point still stands. There's there's multiple kinds and levels and so on.
Yeah, one thing that I think it would be good to kind of spell out is also like, there's not just secure or trustworthy is like a very broad thing that could have lots of definitions. If it's helpful, I think, to break it down into components. One of them is integrity, which again is like hard to define. I think in maybe the blog post or something like that, we talked about defining that as protection against tampering, which again is like, how do you define that? If I kind of feel like the solutions for integrity, meaning like prevent people from tampering in a way that like the organization that owns the software does not want you to do, so like an individual tampering with it or something like that, or some third party, then the solutions are probably different than ones that are around like code, like code quality, or like free of vulnerabilities or things like that. That's another important aspect, perhaps even more important. But like, it seems like it's two different problems that have similar but not necessarily the same solution. So anyway, in terms of, I was going to say, kind of coming back to the reference architecture, this was more of just like sharing a work in progress thoughts. If you're interested in collaborating on this or have any feedback, either comments on that or email, I'm happy to get any help on that or feedback. But just more of like, I want to share thoughts.
Got it. So I'm trying to distinguish. I think you're right. They're different kinds. I'm trying to figure out how to verbally distinguish these different kinds. I'm struggling a little bit. I mean, it sounds like one thing is, did you run this process, and the other is, can I trust that process that I ran? Or how trustworthy is the process that I ran, and was this a process that I ran? That may not be exactly right. I'm struggling a little to capture if somebody has a better way of capturing.
Yeah, I kind of, one way we've been thinking about it at Google is like, remove the trust in people. We shouldn't have to trust that people have done the right things. Can we trust the code? And so if we link everything back to software, meaning like code and configuration, and then we could do analysis on that and look at properties of that. If we can remove all the places where people have any control over it, and we have some sort of guarantee that like that software is what actually did it, that is kind of like a helpful.
Okay. Yeah, and I would add the way you, I think one of the key things, and this comes back to some discussions we've had earlier, is if you want to verify it, the best way is to show that you can reproduce it. Which brings us back to the reproducibility. I know you don't want to add that in, but if I don't trust the people, and I'm not sure I can trust the underlying systems, I'm running out of options. Michael Lieberman, are you saying something? Because I can't hear you.
Oh, no, sorry. I guess actually one thing is I do wonder, I think as much as we can remove the need to trust people, I agree with that sentiment. I do think that there's, at some point, you have to trust somebody to have done something, because otherwise, no code got written in the first place. So, but I do think that, yeah, like from I know I'm mostly talking about this from an end user that doesn't, like, we're not selling, you know, my day job, we're not selling software. We're, you know, the only software that we have is stuff like, you know, online banking, that kind of thing. From our perspective, we do still have that requirement to understand, like, how do we know what vendors we can trust, right? Like, how do we know? And it's, in the open source world, I think it's a little bit of, it's a different sort of problem, right? I mean, it's similar, to be clear, but when it comes to start talking about, like, hey, do I trust vendor X to have done these things? And they also don't, maybe they don't want to reveal how they built all their applications. That also complicates it.
I see we're running short on time. So I assume that we're gonna, when we come back, we'll probably continue this discussion, and also whoever slipped in the other one will admit their guilt.
Can you trust them?
Currently, I don't know who them is.
Probably Kim being that.
Yeah,
She's not here
I
right
think so too. Yeah, I think that's the most likely culprit.
Okay, any other, we're basically out of time. Any other issues before we go?
Is this meeting cancelled next week? Or it's not next week, right? It's bi-weekly.
Bi-weekly.
Yeah, never mind. Sometimes the meetings all blur together.
Yeah, I think we're done.
Thanks, everybody.
Yeah, thank you, everybody.
Thank you.
Thank you all.
Everybody, bye.